Here we are in section 3.1, exercises part A, numbers 13 through 21. The instructions are to solve, which means to get x by itself. Now here's our x right here. Now some of you may have seen ways of distributing the parentheses and a whole bunch of stuff. For the purposes of this assignment, we're really focusing on the undoing, the going backwards that happens in algebra. And so we're going to look at it in a little bit easier light. This is x. Now notice what happens to x. We times it by 3, and then we subtract 1, then we divide by 7, then we add 2, and then we take that whole solution, and then we take that whole result right there and times it by 5 to get 35. So we can do this by just undoing what happened. So let's do that piece at a time. The last thing to happen was that we times by 5. So let's divide by 5 on both sides. Divide by 5, and we get, this is canceled. The 5 divided by 5 over here is gone, and over on the other side we just get a 7. So we rewrite what we have here, 3x minus 1 over 7 plus 2 equals 7. Great. That helped us out quite a bit. It made the problem much, much smaller. Now let's get rid of the next outside piece, which is the 2 here. What's the opposite of plus 2? Minus 2. So we subtract 2 from there, subtract 2 from there, and this 2 over here cancels. It's gone. Plus 2 minus 2 is gone. That's why we did it. So we now have 3x minus 1 over 7 equals 7 minus 2 is 5. How do we undo this divided by 7? That's the next outside piece. We times by 7. Times by 7, times by 7. These 7s cancel. We don't times by 7 up there. We did that to get rid of it, to undo it. And now we have 3x minus 1 on this side of the equal sign, and on the other side we have a 35. Okay, how do we get rid of that minus 1? Well, we add 1. And we add 1, and we get 3x equals 36. These two cancel on this side. That's why we added 1, was to get rid of it. Now how do we get rid of that times by 3? Well, we divide by 3. Divide by 3. And these two cancel, and notice how the x is left all alone. And we get x equals, what's 36 divided by 3? X equals 12. Let's double check our answer. And there we have x equals 12. Good. Number 14, very similar one. Here we have the x right here in the middle. Notice if you were the x, the first thing that would happen is that you would be multiplied by a negative 2. By order of operations, negative 2 would happen to you first. And then you would subtract 8, then that whole result would be divided by 6, then added 7, then all in parentheses timesing by 3, then subtracting 3. That's what order of operations would do. Well, algebra undoes that and goes backwards on it. So let's do that. Let me see. The last thing that happened if we started with x would be that we subtracted 3. So we undo that with a plus 3. And those two cancel. So we're left with all of this, 3, big parentheses, minus 2x minus 8, all over 6 plus 7 equals 15. Okay, the next outside one is this 3. How do we undo a times by 3? Well, we divide by 3. And divide by 3, make sure you do it on both sides of the equal sign, and it goes away over there, and we are left with minus 2x minus 8 over 6 plus 7. We don't even need the parentheses now because we're not multiplying it by anything, equals 5. Okay, now what can we get rid of? The furthest outside thing, peel off that outer leaf, is the plus 7. So we're going to subtract 7 on both sides. Minus 7 minus 7. And they're now gone. So we now have negative 2 minus 8, and negative 2x minus 8 over 6 equals a negative 2. All right, how do we undo this divided by 6? Well, we times by 6. That's the opposite of it. So we times by 6, and this guy cancels. We don't have to times the 6 up here. We did that so that it would cancel on the bottom. So what do we have left? This problem gets smaller and smaller every step we take. Equals a negative 12. Good. So then how do we undo a minus 8? That's subtract 8. We do it with a plus 8. Plus 8. These guys cancel right over here, and we're left with negative 2x equals negative 4 is what that looks like. And then when we divide, well, do we add 2 to both sides? That is a negative 2. No, we don't. It's attached to the x by a multiplication. We started clear up here with x timesing by a negative 2. That was the first thing that happened, so it's the last thing we undo. And we undo multiplication with a division. These guys then cancel, and we are left with x equals a positive 2. Let's double check that answer. X equals 2. That's good. Now these two problems were really quite long, but they should emphasize the point that you can, no matter how big the problem is, if the x is right there in the middle, all these things can be peeled off one layer at a time until you get down to the bottom. And that's the whole point of algebra. Now let's do some of these other problems where it's not so long of a process. We're trying to solve and get m by itself. How do we undo a negative 3? Well, with a positive 3 onto both sides. These go away and we get m equals 21. Done. Let's check our answer. That was nice after those other ones. M equals 21. Number 16, 7/3 t equals 14. How do we get rid of a timesing by 7/3? Well, we divide by 7/3. Let's make sure and do this on the other side. Divided by 7/3 is the same thing as timesing by 3/7. Okay, that's what division of fractions does. So 14 over 1 times 3 over 7 is 42 over 7, gives us 6. The other way we could do it is to cancel those. Well, 14 divided by 7 is 2 over 1. 2 times 3 is 6. Or you could punch that in your calculator. Let's check that answer. T equals 6. Number 17. Negative 13 equals 5x plus 7. Oh no, the x is over here on the other side of the equal sign, but that doesn't matter. What's by the x? It is timesing by 5 and then adding 7. Let's go backwards and subtract 7 from both sides, and we get 5x equals negative 13 minus 7. They are both negative, so it goes even further negative to negative 20. Divide by 5, divide by 5, and we get x equals a negative 4. Let's double check that answer. X equals a negative 4. That is correct. Number 18. Ooh, this is almost as big as these, but not quite. This is solving for x. We're trying to get x right there by itself. It first timeses by 5, then subtract 6, then divide by 4. So how do we undo divide by 4? We times by 4. Do it to both sides to make sure we balance that equal sign. And we have 5x minus 6 equals 12. How do we undo a minus 6? With a plus 6. Plus 6. And we get 5x equals 18. How do we undo a times by 5? Well, we divide by 5. Divide by 5. And we get x equals 18/5. Does that reduce at all? Well, we could write it as x equals, if you punch that in your calculator, 18 divided by 5, you'll get something like 3.6. Either one of those would be okay, or 3 3/5 would be okay as well. Let's look. X equals 18/5 or 3.6, either one. Number 19. Negative 3/8 x minus 4 equals 20. Well, how do we get rid of a minus 4? Plus 4. We get negative 3/8 x equals 24. How do we undo a timesing by a negative 3/8? Well, we divide by negative 3/8. So we divide by a negative 3/8, divide by a negative 3/8. So we get x equals, now how do you divide fractions again? That's right, we take 24 times a -8/3, timesing by the reciprocal. Or if you punch that in your calculator, you would get the same thing. 24 divided by 3 is 8, times by 8 is 64. So this is a -64. That's what x will equal. And if you'd like to punch that in your calculator, that's all right too. Let's check that answer. X equals a -64. Number 20. 12 plus 2p equals 3. So 12 plus 2p, we're trying to get p by itself. So timesing by 2, we're going to divide by 2, but we'll do that last because it's closest to the p. So subtract 12, and we get 2p equals 3 minus 12 is a -9. How do we undo timesing by 2? We divide by 2, and we get p equals -9/2. And let's check our answer. P equals a -9/2. And number 21, we have 0.4 equals 0.4y equals 78. This is 0.4 times y, so we divide by 0.4. We get y equals, that one I'm not able to do in my head, so we're going to do it here. 78 divided by 0.4 equals 195. Let's check our answer on that one. And y equals 195. Good.